All right, so today we're going to look at zeros of a quadratic function. If we look at the top, it does tell us that a zero of a function is the x value that makes the value of the function 0. The zeros of a function are x-intercepts of the graph of the function. A quadratic function could have 1, 2, or no zeros. The first thing we're going to look at is what would be a picture of each of these situations. When you have 1, 0, that means that you are only crossing the x-axis one time. Well, with a parabola, the only way that's going to happen is if our vertex lands on the x-axis. That is the only time you would see only 1, 0. 2 zeros is going to be when your parabola crosses the x-axis twice. This is going to be our most common. So it could cross twice. In this situation, it could cross twice here. There are several options for a parabola crossing our x-axis twice. The last situation is when it's no zeros. And this is when the x-axis is not touched at all, and it will not be. So one example would be if our vertex of our parabola is above the x-axis and opening upward. Another example would be if it was opening downward, that the vertex would have to land below the x-axis, such as this. So these are each of our situations for what having 1 0, 2 zeros, or no zeros looks like. Those are the only options with quadratic functions. Now, number 1 has us looking at a graph that has already been graphed for us. It says, look at this graph, negative x squared minus 4x. Remember, the value attached to your x squared is always your a value, so I should be knowing already that I'm looking at a reflected graph, and my a value is 1, which means that it should have the same transitions as our parent function, 1, 1, 2, 4, from the vertex. They're asking us to identify the zeros. Well, when we're identifying the zeros, we're looking for our x-intercept. So I want to look at my x-axis. This graph crosses my x-axis in 2 places. So there are 2 zeros on this graph. The first one is when x equals -4, and the second one is when x equals 0. So the way that we report this is we say x equals -4, comma, 0, because these are the 2 zeros is when x is equal to -4 and x is equal to 0. On number 2, they're asking us to graph this ourselves. Now I need you to grab a calculator. You should already have one at your desk, but please grab a calculator, and we're going to type this in on a graph using your calculator. Once you have done that, I want you to hit Control T to pull up our points. It should give you a list of points. A lot of them are going to be decimals, but the 4 that we can pull out that are going to be whole numbers should be -1, 0, -4, 0, 0, 8, and 6, 8. Now I'm going to graph these on here. Do not just look at the picture on your calculator and try and draw it. Use accuracy by using these points to graph. So -1, 0, -4, 0, 0, 8, and 6, 8. All right, now that we've done that, we can go ahead and connect these to form our quadratic function. Now that we've done that, we can address what is being asked, the zeros of the function. Again, we are looking at where does this cross the x-axis. Again, we should be noticing that this is going to have 2 zeros because the vertex does not lie on the x-axis and it is not sitting above or below as a whole parabola. Our two zeros for this graph are going to be when x equals negative, this first one was negative 2. Negative 2, 0, so it should be about right here. Ignore this. Right here, negative 2. So our x values are going to be when x equals negative 2 and x equals negative 4. Sorry about that. Y'all are probably moaning and groaning about that at this point. All right. So again, our zeros should have been when x was negative 2 and x was negative 4. That is when it crosses the x-axis. All right. Number 3. We're going to use our calculators again. However, we have got to make sure that we're typing in the correct thing into the calculator. We cannot put this in the calculator like this. What we need to do is we need to move everything over to one side. So the way to do that is going to be plus 2 plus 2. So now my new equation with everything on the same side is 2x squared minus 2. Now I'm ready to graph, and I can actually graph this one without a calculator because I have my a value, and this means that I'm shifting down 2. So I can move my vertex down 2, and then I am moving by an a value of 2. So it's 2 times greater for my y value every time. So my movement from my vertex according to the parent function would be over 1 up 1. Well, now that it's 2 times greater, it's over 1 up 2. And I would repeat that on the opposite side. And then next it would be over 2 up 4, but now I'll be looking at over 2 up 8 because it's 2 times greater. So over 2 up 8 on both sides. Now that I have those, I can go ahead and connect. When it says solve by graphing, solve would mean find your zeros. So here our zeros again are going to be where am I crossing the x-axis. I have 2 zeros again. I have when x was negative 1 and I have when x was 1. So when I write this out, I say when x equals negative 1, comma 1. Now, please note that I am not putting parentheses around this, so I'm not suggesting that it is an ordered pair. I'm saying here are 2 values to solve this that are my x values, the solutions to this function. All right, B, it's asking us to graph this, which means everything's on one side of the equation. So we're good to go graphing this, but next they're saying find where f of x equals negative 2. So we're going to first treat this as our graph to be graphing. F of x equals 2x minus 4. Now again, I can go ahead and graph this one because it's not in standard form with the bx value. I can say that this is moving down 4 and my a value is 2. If I had standard form, I would not be able to immediately grab this and do that. So what I need to do here is I need to say minus 4 is my vertex. There is no left to right movement. Then my a value is 2, which is going to mimic what we did here. Your y values are 2 times greater than a parent function. So originally I should move over 1 up 1, but now I'm moving over 1 up 2. Now the next one would be over 2 up 4 if I was following a parent function, but I'm not. My a value is 2, so again I'm going over 2 up 8. Now I'm going to use these to connect. One thing you should be noticing right now is that we didn't actually have a point that landed at a whole number on our x-axis. However, this is asking us to find when f of x equals negative 2. So what that means is we need to go to where x is negative 2. Where y is negative 2. F of x is the same as y equaling -2. And we're going to go ahead and draw ourselves a dotted line through where y equals -2. By saying find where f of x equals -2. My y value is -2. There are 2 points that cross this line. There are 2 solutions to when my answer to this function is -2. And that's going to be when x is 1 and when x is -1. So next, if we look, it's saying, what do we notice about the solutions here? Well, they're the same. The reason why it's the same is because if we use substitution here, if f of x equals -2, I could substitute -2 in for f of x, which would mean it looks like this. And then if I get to this point, now I can say that actually these two look identical. They are the exact same. I substituted in saying f of x is equal to -2. So instead of f of x in my function, I put -2 in. At this point, if I needed to graph this, I would say +2, +2. This would be what I would graph, meaning my solutions here, when it crosses the x-axis, would be -1, 1. Here I was looking for when my answer is -2. When substituting it in, it creates the same graph. Note that it does not create the same graph if I'm not substituting it in, because I'm separately looking at here's a graph and this is when it equals -2 versus subbing it in for solution purposes. It should not create identical graphs because my functions originally were not identical. It was only once I substituted it in that it would shift it, but then it gives me the same output. All right, if we flip the page and look at our next page, we have 2 more problems to graph. So here again, I've got x squared minus 4 equals -3. I don't have all my information on one side, so I need to go ahead and say +3, +3. So I have x squared minus 1 equals 0. This is now ready to be graphed. Again, I can graph this because it's not sitting in my true standard form. This is an a value of 1, and I'm going to shift down 1. So if I go down 1, here, there is no left-right movement. Now, because my a value is 1, I'm going to map out my parent function over 1, up 1, over 2, up 4. I could even go over 3, up 9 to finish it out. So I should always make sure that I'm mirroring my point. So when I go over 1, up 1 to the right, I also go over 1, up 1 to the left. My solutions are again where it crosses the x-axis. Well, it crosses at -1 and at 1, so I would say x equals -1 and 1. These are the solutions to this graph. Number 5, 2x minus 8 equals -x squared. On this one, I need to get everything on the same side, so I'm going to do plus x squared. So then my new equation is x squared plus 2x minus 8. Now this equation is where I'm going to need to make sure that I'm using my calculator. So go ahead and take a moment to plug this in on a graph in your calculator. And then once you plug it in, Control T to get your table to give you points to use on here. Do not guess where these should go based on what you think the picture looks like. So the points I went ahead and pulled out from my graph were negative 4, 0, 2, 0, 0, negative 8, and negative 2, 8. All right, hopefully at this point this is what you have on your graph as well. So we're going to go ahead and connect these. If you found more points that were whole numbers, that is completely fine. When I connect these, again, I'm looking for where does it cross my x-axis. Well, it crosses when x is equal to negative 4 and when x is equal to 2. You may have also gotten a vertex of negative 1, 9, negative 9. All right, and our final problem. They've given us a graph and they've given us 7, well, A, B, C, D, E, 6, and 7 to look at. So the first question says, what are the solutions when x squared plus 3x minus 4 equals 0? Which means, what are my x-intercepts? So if we look, here's my x-axis. So I'm looking for the points when the answer equaled 0, and that would be at negative 4 and 1. And we know that because it's when it crosses the x-axis. B is asking us how many solutions does the equation have when x squared plus 3x minus 4, which is the graph we have, is equal to 6. So now what we're going to do is go look for where our graph equals 6 as a y value, which is this line here. So when the answer is 6, I plug in a certain number, I'm getting out 6. That's going to be at this location and this location. So again, how many solutions? 2. The 2 places are going to be negative 4, negative 5, and positive 2. It's not asking us for those, however, we could give them. But we found these by saying, well, when I get a 6 as an answer, these are my 2 locations. So we graphed y equals 6 and found points that crossed it. And again, this is the answer. This is what I would put into my equation to get an answer of 6 out. When they're asking us this, they're saying, when would I get an answer of 6? Just like here, when would I get an answer of 2? Well, if I plugged in x value here and I plugged in x value here, I would get a value of 0. If I plugged in a value here and I plugged in this value here, my answer would be 6. C is actually going to go ahead and ask us those answers, what they are. We just said that it was when x is negative 5 and when x was 2. That is when I plug these two values in, I would get 6 as an answer. So I'm looking for what x value could I plug in here to create a true statement. D is saying, when we look at our function, x squared plus 3x minus 4, we want to know how could I get an answer of negative 6. So I'm going to look for y values that are negative 6, which would be at this point here and this point here. If I plug in a 0, if I plug in a negative 2 or a negative 1, I would get out a negative 6. So my two solutions would be when x equals negative 2 or when x equals negative 1. E is asking us what is the solution when x squared plus 3x minus 4 equals negative 6.75. Well, if we look on here, our graph stops here. This does not reach down to an answer of negative 6.5. Negative 6.5, although it doesn't fit on this graph, it would fall about right here. So then I would ask myself, are there any points on this graph that hit this line? And the answer would be no. So the solution when x squared plus 3x minus 4 equals negative 6.75 are none, or no solution. There are no points in which you would get this as an answer if you plugged in that value. Our graph does not actually go that low. So it says, are the zeros and the solutions to a quadratic the same? So zeros are going to be when we set the quadratic equation equal to 0. Solutions could be a variety of things. A solution is when you're asking, when is this my answer? So yes, you could have a 0 as a solution. However, there are other solutions to your graph, just as we've listed here. What are the solutions when it's equal to 6? Well, these are. Those aren't our zeros. These are the solutions when I'm looking for this value. Here, what are the solutions at negative 6? Here, these are not my zeros, but they're solutions to satisfy this value. My zeros would be where I'm crossing the x-axis, so they are solutions when I'm looking for an answer of 0. So it would be yes, but not always. There are solutions we can get that are not always just the zeros, as we have found throughout this problem. Number 7, some characteristics that I noticed is that this would be a minimum. Another thing I noticed is that my A value up here, I know my A value is 1. Whatever number is attached to this, no matter standard form or vertex form, this would represent my A value, so it has an A value of 1, so its movement is going to be the same as a parent function. You do have homework tonight going over this, but don't worry if you are struggling. I apologize for the coughing in my video. Hopefully you were able to follow along. If not, it is on Canvas as well. There are tutorials both after school today and before school tomorrow. So Wednesday after school is Mu Alpha Theta. Thursday before school is with Coach Alama. If this lesson made no sense at all to you, you might touch base with one of them. I will be back tomorrow, so we will be continuing to discuss solutions or zeros of functions in order to prep for our quiz on Friday.